what we're going to do right here. This is our first x-intercept finding. This is exciting. So hold on to your seats. Actually, let's actually do it here. Let's actually do an example here. This is a powerful example. Okay, this one's so exciting that I'm actually drawing a happy face beside this one. It looks a little bit creepy happy face, but go with me again. Okay, but there's a happy face. Yeah, it's supposed to be a star happy face. That's what it's supposed to be. Okay. This is super duper tremendously important, okay, what we're doing here, okay. You'll probably use this. He's not focused on us right now, but in calculus we use this 10 times a day, 1,000 times a day, 100 times a day. In grade 11 we'll use it, again, maybe not 100 times a day, but twice a day at least, okay. Okay, so we're solving now for 2 things equal 0. What is the symbol between x minus 2 and x plus 3? Times, thank you, whoever said times, wonderful. Okay, because brackets means like times it, okay? So this is what you're thinking. What I'm saying is I'm getting 2 numbers are going to multiply together to give you 0. Okay, so what does that mean? If 2 numbers multiply together to give you 0, what does that tell you? One of them has to be 0, okay? Excellent. Okay, which is awesome. Okay, right? Like if I were to say to you, Aiden, what is 0 times 8.3 billion? 0. Good. Okay, wonderful. Caleb, what is 0 times negative 4 times 3929x 4394? 0. Good. Okay, right? Then that's the thing. No matter what the other bracket is, the only way to get 0 is to times by 0. So what this means to us mathematically is when I'm solving this question, I can say then that either, whoever's beeping, please stop beeping. That either the left-hand bracket is equal to 0 or the right-hand bracket is equal to 0. Are we okay on the logic that I'm using here so far? So now is sort of saying yes or no.
So you just have to keep it right there?
Yes. Because we're solving for x, that's what we're going to do here. Jasmine, I'm going to pick on you. On the left-hand side, if it says x minus 2 equals 0, can you solve for x, please? Good. Okay. So either you can move the 2 over or just think to yourself 2 minus 2, so x is equal to 2. Great. Wonderful. Tremendous. Yes?
What if x minus 2...
Good. All right. Emily, can you do the same thing on the other side? If x plus 3 equals 0, what does x equal, please? Negative 3, not 3, negative 3.
Okay.
So remember, right, when you're going across equal sign, right, just going to flip the signs. Okay. Now, if you're saying to yourself, I don't believe that's true, it is. Okay. If you plug in 2 to this equation, 2 minus 2 is 0. So that'll make the left-hand part 0. If you plug in negative 3 plus 3. What these are going to turn into are going to be our x-intercepts. So when we graph these, what this is going to mean is that that's going to be 2 comma 0 is going to be our point, and negative 3 comma 0 is going to be our other point. Okay. So if you remember when we drew our graph yesterday, and this is going to be a rough sketch. Please don't tell your parents that I did a graph like this, okay? But when you did it, basically what that's saying is we're going to have 1 point here and 1 point here. And the parabola is going to look something like that. Okay? We'll deal with the rest of the parabola in a second. Okay? But that's the logic. that we're trying to use there. Okay? Sort of makes sense? We're sort of good so far? We'll do lots of examples so it'll all make sense in a little bit. Okay? Okay, there's one other thing that we're going to say here that's important, okay? So basically back to our note here if you can. We're going to say, therefore, if y equals a, x minus s, x minus t, our x-intercepts are s comma 0 and t comma 0, right? So whatever those numbers are, the opposite number that's in there is going to be our x-intercepts. All right, sorry, yeah.
What does S and T stand?
They're just happen to be numbers, right? So, like, it could be x minus 3, x minus 4. These are just like general, like, it's just like a general equation. It's like y equals mx plus b, it's the same thing, right? They could be any numbers that go in there. Yeah. Go ahead.
Isn't it x, y, though?
Well, because for our x-intercept, we said y is equal to 0, right? So our y value is going to be 0. And just so we show it over here, what that means is that this bracket has to be 0 or that bracket has to be 0. So if you were to make x minus s equals 0, moving it across, x would equal s. And the same thing, x minus t equals 0, x would equal t. And the 0 part we already know, right? So that's it. Okay, one last thing I want to talk about, then we'll get going here to our examples. The next thing is we're going to say the axis of symmetry. We're going to say divides the parabola in half. And is the x-coordinate of the vertex. So x is going to equal s plus t divided by 2. So what this actually means is add your x-intercepts and divide by 2. Okay, so we will go through lots of examples to make sure this is good. This is all s's and t's and x's and y's, so it's horrible. Once you get 3s and 4s and 1s and 6s, it'll make a lot more sense, okay? So we'll get the graphs going and all this stuff too. So just scribble down the terminology here, and then we'll get to the actual usage of it here in a sec. Now this looks scary, okay? It is not scary. Okay, once you do a few of these, you'll say, I got it, no problem, and all is well. Here we go, example 2. It's going to come right now. I'll give you a second to split. Yeah. We'll go through how to find all this stuff right now, which is an example. So example 2 says, we're going to say for the equation y equals 3, bracket x minus 3, bracket x plus 1. Find the y-intercept. The x-intercept, axis of symmetry, vertex, and graph it. Okay, there's an explanation part again because this is wicked cool, awesome, powerful stuff. Okay, this is everything together. Now I see Luke shaking his head saying, I hate graphing. Too bad. Okay? Graphing is unfortunately part of math. Okay, so when I was your age, actually after I was your age, I don't remember when I was your age, but when I was 18, I hated graphing. Okay, like I loved algebra, like I was like Luke, I said, yeah, give me like example C and times it by 100, I'll do it. Okay, but to draw parabola, no thanks. When I got to university, I saw the value of graphing, so I'm sorry you're not at university yet, but one day you will see the value of graphing. So I'm going to start here, just top to bottom here. And I'm going to pick on you to begin with, please. So I'm going to start with my y-intercept. That's what we're going to find first. All right. So thinking back to grade 9 or earlier in this year, earlier in this semester, do you remember how to find the y-intercept? Set x equals 0. Very good. So what we're going to do is we're going to start with the equation y equals 3, x minus 3, and x plus 1. And what you're going to do is everywhere you see a x, you're going to plug in a 0. And I'm going to get out of the way to make sure this is good before I keep going here. Okay. So we said a y-intercept is to set x equals 0, so everywhere I saw an x in my equation, I plugged in a 0. Are we good so far? Sort of good? Okay, Bailey, I want to pick on you. Bailey, what is 0 minus 3? Good. What is 0 plus 1? Okay, so what Bailey has correctly done for us is she has simplified our equation. So what she did was she just made the brackets nicer, okay, to make them look better. Molly, you're going to be up here right now. What is 3 times negative 3, please?
Negative 9.
Great. What's negative 9 times 1? Great. So y is going to be negative 9. Okay, now I'm going to take a step back because I'm too excited. I love parabolas. Okay, so just take a second, make sure we get caught up. And think about this we're going through. Okay, so what we're just doing is here, in order to get the y-intercept, we're just going to set x, simplify, and life is hopefully good. All right, Aiden at the back. It's time to shine. What coordinate will this be? What comma what when I graph it?
Negative 0, negative.
Where did you get the 0 from? Right, excellent. I hope everyone heard him say that, right? Because what people do, they'll get all confused. Right? Our first point is going to be x equals 0. That's what we're going to do. Okay? What I'm going to do now, as I'm giving Hannah a headache, I'm sorry to give you a headache, I'm going to graph this right now to make sure life is good before I can hit it. Okay. So what I'm going to do is I'm going to graph this right now. Okay? Right? So again, if you can do this, I'm going to squirrel down. Okay, so again, I'm running a list of paper. What she has done is she has split it into 4. This is good for this graph, okay? I'm going to give you a hint. There will be a lot of negative numbers here. You might have to go down to about negative 14 or negative 15 as well. Okay, so adjust your scale so you can do so. Okay. So what I'm going to do is I'm just going to plot this. The reason we do this in parts for my graph, I'm going to graph some points separate, because generally the x-intercept is easy to find, the y-intercept is easy to find, the vertex is difficult. Okay, so I'm going to just graph the y-intercept first because it's normally the nicest to find. So I'm going to, Caleb, since you're sitting all by yourself back there, you're going to give me everything I have to do to set up my graph, every single thing I need to do. Go ahead.
Well,
Great. With a nice, beautiful ruler is what you're going to use. Okay, so for those people that borrowed rulers from me today, good. Okay. Oh, goodness gracious. Oh, goodness. There we go. Okay, Caleb, you're not done. What else should I do to my graph, please? Scale. I said probably get down to about negative 15. That's how low you should go. All right. So, because we don't know this yet, but again, this graph's going to look like a U, like they all do. All right. And what do we know about the vertex point? Somebody tell me 2 things we know about vertexes. Yes. Anything? The lowest point. Good. So the thing that I wanted to get from that was, if I already have a point at negative 9 as the x-intercept, and the vertex is going to go lower, you've got to leave some more room underneath. Okay. The second thing that I hope somebody would say is also the middle of the graph, right? So that's going to be like the middle will be the 2 arms on either side. So I said to get down to about negative 15. Hopefully I can do that. If you need to count by 2s or 3s, that's fine. How are we doing for time now? I'm not going to rush. Maybe I just won't get through as much as I wanted to today. Shoot. Okay, on the right-hand side, I'm going to suggest that you count by every other one in case we need a half in there. Okay, so I could suggest probably going like that. Okay, Caleb, you're not done yet. I need a few more things before I start plotting points. You certainly do. So I sort of hinted and put that on there by mistake. Okay, so there you go. There's another arrow. There's another arrow. And one last thing before I pass on to somebody else.
Oh.
That's a Y. Thanks. It's getting there. Yes, you were. Okay, so there's your y-axis and there's your x-axis. Now again, you guys as a class are very good at labeling things like that. Please take the time to be accurate. Okay, so Aiden at the front now. We're going to graph our first point. Where's 0 and negative 9? Yeah, good. So it's going to be right on the axis here. Okay, so x is going to be 0, y is negative 9. It's going to be sort of like this. Again, I do circles on my graph just because it's easier for you guys to see. If you just want to do points, that's fine as well too. Are we okay on the first thing? I know you guys hate graphing. I'm sorry. I'm keeping you up on a Friday. I apologize. It's 10 to 10. You should be awake. You're always like this. Okay, let's do our x-intercepts right now. Okay, so this is a new part. This you should have been able to do before, subbing in values. This is a little bit different. So I'm just going to the next page here. So I'm going to say y equals, so for my x-intercept. All right, Cassie, how do we find an x-intercept, please? Set y equals 0. So you're solving the equation 0 equals 3. Bracket, I lost my equation. X minus 3 and x plus 1. Okay, I'm going to get you started on this. Okay, because this is the new tricky part from last time. I'm going to ignore the 3. Why can I ignore the 3? Why can I ignore the 3? Well, pretend you're solving for x and it was like 3x equals 0. Why can I get rid of the 3? No, fraction has to do with it. Alice, go ahead.
Because if you distribute 3 to x, then it would be x but times 3.
Right, that would work. Yeah, good. I was thinking something simple. That's true that would work. I was just thinking I could divide this by 3 and divide that by 3, and there's no big deal. Okay, right? So I'm just going to ignore that. What I am going to use, though, is I'm going to use these two brackets here. So I'm going to say on the left-hand side, I'm going to say x minus 3 equals 0, or x plus 1 equals 0. Is it okay to have 2 x-intercepts? Yes, it totally is. 2 x-intercepts are fine. Okay, that's perfectly okay. All right, Alyssa, I'm going to pick on you right now. On the left-hand side, how do you solve for x here, please? Good. So what is x going to equal? Good. Now, Alyssa, you're not done yet. What point will that be on the graph? What comma what? 3. Where do you get the 0 from? Very good. Okay, right? So that was the first step, was set y equal to 0. So my point's going to be 3, 0. Does that make sense where that came from before I move on here? Okay, because this is horribly important. This is what I want to teach you guys today. This is horribly important. I have a question, but is it? Yes? You have to do them both, actually. Okay, because the way this is going to work, right, it's going to be U sort of like this. So there should be two answers there. All right, Jenna, can you do the same thing with the right-hand side, please? Is x going to equal? Great. What point will that be on my graph? Great. Now I'm going to put those in here right now. Okay, so negative 1, 0 is going to be over here. And 3, 0 is going to be over there. Now we have two last things, which are my axis, symmetry, and my vertex. Are we okay on where those first 3 points will come from? Okay, so I think I'm not going to do another lesson after this. I'm going to do one more example, like to make sure you've got this down rock solid. When I'm not here on Monday, I'll do the second half of the lesson. So I don't think I want to rush through this too much. Okay. Axis symmetry. Are we okay on this? Everyone, close your eyes for a sec. Is anyone not sure about what just happened for the x-intercept? Please raise your hand if you're not really sure. You guys are so brave and dishonest to me. That's fine. Okay, open your eyes, please. Okay, axis of symmetry. It's going to come next. And this is another thing that's new, and I'm going to take you through this. When I say me, I mean Spencer. Spencer, can you flip to the previous page and tell me what the axis of symmetry is? Nice and loud.
The axis of symmetry divides the parabola in half and is the x-coordinate of the vertex.
Yes. Okay, so it's going to be, what we're saying is it's going to be the middle of the parabola. That's what it's going to be. Okay, now, when I teach this in applied, I use the finger method. We're going to use the algebra method. You want to know what the finger method is? Is this. I'm going to start at 3 and 1. I'm going to move my fingers together, and where they touch, that's the axis of symmetry. All right? That's the finger method I use in applied. So it's going to be x equals 1 is going to be my answer. Okay, but I'm going to actually do it with algebra here in a second. So the logic, well, because we can get the fractions and things of this, we will. Okay, so but that's the logic behind it there, right? It's going to be the middle. So the way it's going to work, I'm just going to do it with an equation. I'm just going to say x equals 3 plus negative 1 over 2. Can somebody please tell me where I got those numbers from? Yeah, now go ahead. Those are the two x points, okay? So 3 plus -1 divided by 2. Okay, Calvin, what is 3 minus 1 equal, please? What is 2 divided by 2?
1.
Good. So the axis of symmetry, I'm going to draw it like this. It's going to be a tiny dotted line. So x equals 1. And I'm going to put down an axis of symmetry. So what that means is that's going to be the middle of your graph. It's going to be like that. So if you're folding up, you can do it like a folded paper thing. Please don't fold the paper. Okay, right, but the idea is that's like the middle of your graph. Right, okay, so it should be a perfect balanced arm on either side. Okay, are we okay on where that came from there? Again, if you want to use the finger method to get started, that's fine to confirm, okay? But we're going to get to fractions and all that weird stuff here soon enough, okay? So we don't do that in applied with fractions, so that's why I don't do that. Okay, now here's the moment of power in this classroom. This is why you guys are superior mathematicians. How am I going to find my vertex now? So if I know the x value is 1, how would I get the y value? Go ahead, Jenna. Please. Great. So we're going to say to get y, sub in x equals 1. Wonderful. Tremendous. Awesome. So I'm going to find the vertex. So we know where the x is going to be, right? The y is going to be, I'm going to scroll down a little bit here. Hopefully the top is covered, okay? So I'm going to start with y equals 3 bracket x minus 3, x plus 1. And everywhere I see a x, see an x, I'm going to plug in a 1. Okay, now if you're saying to yourself, wow, this is a lot, we're going to do tons of these today, so don't worry. All right, Megan, excuse me, what is 1 minus 3, please? Good. Desiree, what is 1 plus 1, please? Great. Natalie, what is 3 times -2, please? Great. All right. And Emily, what is -6 times 2? What's -6 times 2? -12. Okay, so here comes the magic moment. What is my vertex going to be then? What, comma what?
1, 12.
-12, yeah. Okay. Wonderful, okay, so therefore my vertex (1, -12), which is going to be down here. Now, the reason I want you to graph as you're doing this, does that look like a parabola? Well, sort of. Okay, when we connect the dots, it will. For the admiration, whoever says this, I'll be horribly impressed. If somebody wanted to put another point on the right-hand side, what point could you put in and why? Anna, go. 2 and negative? How'd you get that? Yeah, right. Remember we said, okay, just wait one sec. So remember we said it's like a mirror image, right? So if you take a look at this, if you're going 1 unit over to get to here, if you go 1 unit over here, right, it's supposed to be a symmetry, right? Let's connect the dots and we're done. Oh goodness.
Do you have to put the opposite dots in?
No, but it helps you to make your graph a lot nicer. Yes.
So did you get x from like the graph?
Yeah.
Would it matter if you have used 3?
One more time here for the vertex, you mean?
Yeah.
Yes, it would have, because that's the whole idea of the axis symmetry. It tells you where the vertex is going to be. Like it tells you left and right where the vertex is going to be.
So if you had used 3, it would have been 2.
If I would have used 3, I would have hopefully got 0, right? Because if you would have plugged it in, like 3 minus 3 would have canceled out. Okay. I need 2 more things before I'm done this graph. What are the last 2 things? There you go. Arrows. Okay, definitely. Okay, there will be someone in this class. Let's call him Luke. That would not give me arrows for that. Okay.
But I did.
Good. There's one final thing I need before I'm done this graph. Luke, go. Title. Okay. So this title is going to be awesome parabola, which I'm going to call y equals 3 bracket. What is it? X minus 3 and x plus 1. Okay. Okay. I'm going to hit pause in the video, and then I'm going to give you guys one to try. Or do you want me to take you through this again? Do you want me to take you through it again?
Yeah.
Yes? I can if you want, yes. I'll hit pause and then you can think of your question. Okay, pause.
That was just the next.